Anytime I give you a pyramid, your base is either going to be a regular polygon or a rectangle. And the reason for that is those are the only ones that have the specific information that you'll be using to set this up. Okay, if we label what we have here, so this equilateral triangle has sides of 6. The height of the pyramid itself is 10. Okay, and so when you're looking at this, we should be able to find the area of our base. So the total surface area is going to be our base plus our 3 triangular sides. And our base is a triangle. So again, really what we're looking at is we're looking at one triangle plus 3 more triangles. Now each of these 3 happens to be the exact same because all of their bases are the same measure as well. So really we're looking at the area of our base plus 3 times the area of one side of this triangle. So let's take a look at our base. It might be easier to kind of look at this from the top. If we have an equilateral triangle with sides of 6 and we wanted to find its area, the area is equal to 1/2 base times height. Well, our base was 6 and the height is this measure right here. Well, in order to find that height, if we draw in 2 altitudes, these altitudes are also medians, so they intersect at this centroid. And that centroid, or I'm sorry, when we draw our altitude, we create this 30, 60, 90 triangle. So what is this going to do to our base here? Cut it into 1/2 of 6 or 3, which means our total height is going to be, we have x, 2x, x root 3. So we have this 3 root 3 as the height of our triangular base. So 1/2 of 6 is 3. 3 times 3 gives us 9 root 3. So here's the area of our triangular base. And now, in order for us to find the area of these triangular sides, what we have to take into consideration is this relationship. Here is the height of this side. So our side has a base of 6. It has this unknown height h right here. In order for us to find h, we need to rely on the fact that if we connect these, we form a right triangle. So we have a height of our solid is at 10. That's also the leg of this reference triangle here. We have this distance from the center of our base to this endpoint. Well, that's represented by this. The center of our base is where all these altitudes on that equilateral triangle intersect. And so, because this is a centroid, or the intersection of all those points, it's going to cut our median, this 3 root 3, into a ratio of what to what? 1 to 2 or 2 to 1, right? So that means that this bottom portion right here, which represents this gray distance, is what fraction of the whole height? 1 part to 2 parts, so it's 1 of 3. So what's 1/3 of 3 root 3? Just root 3. So that portion right here, this leg is going to be square root of 3. This other leg is going to be 10. And to find our height here, what can we use to find this missing piece? Pythagorean theorem. So we have root 3 squared plus 10 squared is equal to h squared. Solve. So we square the root 3, square the 10, add them together and square root. So we get the square root of 103 is our height. So that's this measure. And so we can now find the area of this triangle. 1/2 the base of 6, height of root 103, 1/2 of 6 is 3. And so we have this 3 times root 103 is the area of one of these triangles. Final thing, how many of these triangles do we have in this pyramid? 3 of them. So we're going to add that to 3 times 3 root 103. So really we're looking at 9 root 3 plus 9 root 103. and you can add that together, calculate it. Our units are centimeters. It's a surface area, so it's two-dimensional measure. And so those are the steps that you would need to take in order to solve this type of problem. Now, for any regular polygon, this distance right here is the apothem. And for an equilateral, this apothem here winds up being the same as this lower portion of the median. Okay, but for a rectangle, that's going to be the center point and the very middle of your rectangle. So you should be able to use the dimensions of your rectangle in order to find what those are.